Okay, I'd like to get started. I hope that everybody can hear me well. You will all be muted, so if you have any questions, there is a chat option in the WebEx application that you can use to send questions or other remarks. So this webinar will be about Diprofis, and I will go through the basics, I think, from getting set up and then do some barometric compensation, which is probably the most complicated thing in Diprofis. My name is Emiel Dijkstra. I was involved in the development of Diprofis and the divers. Kind of know the program inside out. Currently, I'm the sales manager for the Americas, so that's a slightly different role, but I still remember enough to answer any questions or guide you through the program. So this is the overview of what I am going to talk about. First, starting Diprofis for the first time, setting application preferences, project preferences, barometric compensation, that will be a large chunk of the whole presentation, programming and starting divers, and then where is my data, and finally there's room for question and answers. So what I will try to do, won't try to make it a PowerPoint only presentation, but I will try to switch between Diprofis and the presentation. That's always a little bit dangerous because of the demonstration effect where things might not work as you think they will, but I'm pretty confident that it will work out. So when you start Diprofis for the first time, you must create a project to get started at all, and you have to give it a name. If it's the really first time and you want to experiment, you can call it test. And once you created a project, then the project will be created in a database, and that database can contain multiple projects. So now I start Diprofis for the first time, and if I'm right, then I can create a project. So I call this one demo project. You can call it anything you want. You can even use special characters if that's needed. And once you get started, you will see this window here with some basic information. There's some links here. What's new, what's fixed from previous versions. You can also have links here, click on the links here for the website or frequently asked questions for Diprofis. And if you get annoyed by this screen and you don't want to see it again, you just uncheck the box here and then you click on the close button and it won't show the next time you open Diprofis. So for the application, there's a few settings that you can do. So that's in the preferences. And one of the most important things are the units and the languages. So the languages, there are 7 languages in total: German, English, Spanish, French, Dutch, Portuguese, and Chinese. And you just pick the language you want. And once you change the language, the program will restart, and then it will show in the selected language. I assume most people prefer English in this webinar, so I'll leave it in English. The other thing is units. So if you click on units, you can select a few different units. One is the pressure, which is per default in centimeters of water. You can go to meters of water, feet, or inches of water. So if I change to inches of water, for example, you will also see that the length unit changes accordingly. So you cannot choose your length unit, it will be in this same type of unit as the pressure unit. For temperature, there's a choice between Celsius and Fahrenheit. And altitude, you can use feet or set to feet or meters. For the current divers, there's no need to use this setting. For the older style divers, the slightly bigger ones, this was used as a setting in the diver to be so the diver can be used at different elevations. So I'll change this back to centimeters because I like centimeters more than inches. And that's it for the preferences that you can set in Diver Office. So just to recap, units and language, and then the project preferences that you can set. And I'll jump back to Diver Office. So on the 3 node here, there's only 1 node now because I haven't downloaded any data from divers. But if you are somewhere in, if you have more items here and you click on the project name, then this window that's on the right-hand side will show here. So first of all, you have the project folder that you can set. So the default is C program data, Diver Office, and then the name of the project. And by clicking on the browse button here, you can change that to any folder that you want. Then for exporting your data, there's different options. By default, the MON or MON file format is selected, and there's also a DAT file. The DAT file is a copy of the diver memory that is always downloaded when you download diver data. The MON file is a flat text file, and that can be used to exchange diver data between different computers. The CSV file is a comma-separated value file that you can use if you want to export data to Excel. And the NIPD format is a Dutch national database format that you probably won't use. For the file name format, you have different options. So when you export data, the file name format will consist by default of the monitoring point name, the date, and the serial number, but you can change that. So there's different options. So you can make them all date or whatever. I would recommend you put the monitoring point in there somewhere. You can also select the compensation status as part of the file name. And then for the second part, you can choose of the same options again. And then for the third part, you can select again the same type of options. You can also say I want to have none, and for example, only the serial number. If you do this, then data from the same diver a few times, then the file name will get a sequence number added to it, so you won't overwrite any data. So I'll keep it like it was. And the advantage of this is that you don't, when you export data, you don't have to name every single file, and you have consistency in the exported files. The export on download, if you check that option, it will mean that once you download data from a diver, it will export the data into the formats that you selected above. A slightly more complicated setting is the project time settings. You can choose computer time, standard time or winter time, and daylight saving time. And this is probably more important for longer term monitoring. And then I would choose standard time. So that means that when you are in daylight savings time, that the divers will be programmed with a time that reflects the daylight, that selects the standard time. So we're now 1 hour ahead of standard time. So it would mean that if I would start a diver today and synchronize the time, it would set the time at 12:15 instead of 1:15. The vertical reference datum is a set of names, and it doesn't have any effect on any barometric compensation that you do. So it's just for your own reference, and you can pick anything of this list here. And if you don't know it, then just leave it at mean sea level. So going back to the presentation. The next thing is barometric compensation, and in its simplest form is subtracting the barometric pressure from the diver pressure, and that results in a compensated pressure. So why do we do it? Because the diver measures absolute pressure, which is the pressure of the water column that's above the diver plus the barometric pressure. And then to calculate the water column above the diver, we subtract those two and divide by the density and gravity, and then we find the value of the water column. So why would we do that? Because barometric pressure is not constant, and at sea level it equals to 1,000 centimeters of water, or 10 meters of water pressure, and it fluctuates about 50 centimeters of water over time. And also, if you go up in elevation, for every 10 meters you go up in elevation, the air pressure decreases by about 1 centimeter. So for barometric compensation, you can use a barodiver. A barodiver can also be used if you want to measure shallow water levels. So for estuary and wetlands monitoring, it's also suitable. So coming back to the slide before that one, what is the air pressure range at 1,000 meter elevation? So at sea level, the air pressure is about 1,000 centimeters, which is about 33 feet. And if you go up 1,000 meters in elevation, then the air pressure drops about 100 centimeters. So that means that the air pressure, or the base air pressure at 1,000 meters is roughly 900 centimeters. So then it ranges between 850 and 950 centimeters roughly. And if you go up to even higher altitudes, let's say 5,000 meters, or even go below sea level, let's say 500 centimeters, then the air pressure ranges get different. So if you go up 5,000 meters, then the minimum pressure that you can have is 450 centimeters, and the maximum pressure will be around 1,100 centimeters of water. So all the divers that we currently have measure pressure from 400 centimeters, so that corresponds to a elevation of 5,000 meters, up to the range that you have bought for the diver. So that's either 10, 20, 50, or 100 meters. And the maximum range of, or the range of the barodiver is 400 centimeters up to 1,150 centimeters. So that corresponds to the minimum and maximum pressures that you can find from 500 meters below sea level to 5,000 meters above sea level. So the barometric compensation is kind of important, but it's also a little bit complicated. So go through the basic workflow of what you have to do to make it work. So there's a few options that you have for barometric compensations. Then there's settings that you have to do, there's prerequisites, and then I'll tell something about the results. So if you click on the barometric compensation option, there's three different options. One is you can calculate the water column above the diver, which is the most left option. The option in the center calculates depth to water, and this is probably one of the most commonly used compensation options. And then the option on the right is where you calculate the water with respect to mean sea level. And you want to use this option if you want to compare the water levels of different wells. So how is it calculated? So the first, the center option, the depth to water, it is fairly simple. It's the cable length minus the water column that's above the diver. For the right option, where we calculate the water level with respect to sea level, calculation gets a little bit more complicated. But first we go up from sea level up to the top of casing, then we go down with the cable length, and then we go up to the water column, and then we find the water level with respect to sea level. There's another feature in DiverOffice which can calculate the cable length based on the manual measurement that you have entered. So the manual measurement that you have entered is from top of casing to the water level, or basically any reference point that you have on your wellhead. Then this is a value that you have to enter. DiverOffice will calculate your water column and will add that to your manual measurement, and then it finds the cable length. And then you will see also a calculated cable length in the application. So for the barometric compensation to work, you have to set a few things. One is the name of the vertical reference datum. This is optional. And for each monitoring point, you have to at least set one barometer. So that's the barometric data that diver uses to compensate its data with. Then, depending on the method you choose, so if you choose the left option, the water column above the diver, you don't need a cable length or a top of casing value. If you use the center option, depth to water, then you need to enter a cable length or a manual measurement. And if you use the right option, water level with respect to sea level, then you need also to enter a top of casing value. So in the application, it looks like this. If you click on a regular diver, then the view here changes, and you can set the options here for the barometer, then the cable length, and here the top of casing value. So some of the prerequisites are that the diver data must somehow overlap with your barometric data. You need to have a barometer assigned, and optionally you can use a manual measurement, but then the manual measurement must be within the range of the baro and the diver time series data. Cable length and top of casing are required depending on the method that you choose. So there's a few ways you can compensate data. One is you right-click on the time series in the tree view, and then you click the compensation options. You can go through the toolbar or use a keyboard shortcut. So the first option is useful if you only want to do one time series, and if you want to do multiple time series at once, you're better off using the second option where you go through the menu, view data, or through the keyboard shortcut. So finally, you will get some results when you finish the compensation, and it will tell you which series have been compensated, which were partly compensated, and which series were not compensated, and it will also tell you why it was not compensated. So you can then correct the settings so the data can be compensated. So then in the tree view, you can see the status of the time series. So if there's a check mark, it means that the data is compensated. If there's a little warning sign or exclamation mark, then it means that the data was partly compensated. And if you did not compensate the data, or the data could not be compensated, then it will show as blank data. So now let me try to do that in LibreOffice. So first I'm going to import some example data. So when you install LibreOffice, this data is automatically installed. It is in the LibreOffice program folder and under the examples. And in this case I go for the Waterloo data set, and I open those two files, and I close this. And so this is my diver data, and then here is my barometric data. So a good check usually is to verify that your barometric data is within a sensible range, and in this case it is between roughly 1,000 and 1,050 centimeters of water, which is okay for where we are here. So this is my diver data, and you can see here it ranges from roughly 1,690 to 1,715 centimeters of water. So when I make a first attempt to compensate this data, I'll right-click on the time series and I'll select the compensate option here. And now when I just choose the standard option, water column above diver, and I hit the compensate button, it will tell me that it failed. And in the details of the compensation log, it will tell me why it failed. It says that I didn't assign a barometer to the time series, or to the diver. So I close this and I'll correct. Then I click on the location name, and then I'll select my baro from the list that's under the barometer monitoring point names list. So now if I try it again, and I use this one, and I use the cable length. I have two options here, cable length or manual measurement. I'll stick to cable length for now. And again, it will tell me that it couldn't compensate because I didn't define the cable length. I'll close this, I'll go back to my settings, and I enter a cable length. So I enter 2,000 centimeters as the cable length. And now I try again. And now the compensation worked. So it said that it was fully compensated, meaning that the barometric data overlapped all of the diver data. So I can close here, and now I can see my compensated data in the top of the graph. I'll hide the temperature, because that's not important right now, and I'll check whether my data is correct or not. So we see here that the diver data is around 1,700 centimeters, and if we subtract the barometric data, then we end up with a water column of roughly 1,000 centimeters. A water column of roughly 700 centimeters, and I entered a cable length of 2,000, so 2,000 minus 700 is roughly 1,300 centimeters, which is consistent with the values that I see here. So if you use this method, then the water level should be mirrored roughly with the pressure, because if the pressure goes down, it means that there's less water, so the water level dropped. So this is basically all there is to barometric compensation. So now if I import some more data, I'll go back and I have some data here that I can import. And I'll just go quickly here and assign a barometer. So because I just added more data and there's now 2 barometers, you will see that in the list here there's also 2 barometers. So I have to make sure that I select the right barometer for each diver. So now I'm done. I haven't filled out the cable length. So if I now go to the data window, I can select time series data here. So in this case, I selected all uncompensated data, and I don't show any barometric data points. And then if I hit barometric compensation and I select the left option, and I do that because I didn't enter any cable lengths, and then I hit barocomp, then you will see it compensated all the diver time series at once. So now if I go here and I want to export all my data, and only the compensated data, I hit apply. Now I've listed all my compensated data. I hit export. I want to export only the compensated data. I hit OK. And then it will tell me which files were exported and in which format. And then if I hit the View Files button, it opens the File Explorer and shows me where the files went. And from here I can email or send the data to somebody else. Or if I have used CSV as the export format, I could open the files in Excel. Yeah. So if I close this window and I'll go to my time series again, you will see that the icon here changed from this bare data icon to the data icon with a check mark. If you want to expand everything at once, you can expand all things. Or if you want to collapse, then you can collapse all, and then you can individually expand or collapse the data. So, short recap on the barometric compensation. We have to compensate the data because barometric pressure equals about 10 meters of water, and it fluctuates about 1 meter over time. In diver office, you have to do certain settings, but these settings depend on the method that you have chosen. Once you do the compensation, there's a log file that tells you what happened, and in the tree view you can see what the compensation status of your data is. So the next thing is programming and starting divers. It is more or less essential that you set a unique name for every diver, because if you set the same name for different divers, all the time series data will be lumped under the same name, but they are actually from different divers. And it gets even worse if you name the barometer the same as the diver, then you cannot compensate any data. So by default, when the divers are shipped, they have a default name which is SWS and then underscore the serial number. So for example, SWS underscore A2373. For the barometric compensation, it would be useful if you start the diver before or at the same time as if you start the diver after the baro diver, or at least at the same time. So when you go out to collect data, I know it's not always possible, but end with the baro diver. So then you make sure that your baro data always overlaps completely with your diver data. And to make sure that you start the diver and the baros at the same time, you can use the future start option. So in Diver Office, when you click on the diver button, you will get this screen where you can see and program your diver from. So we go back to Diver Office. I have connected a diver through a reading unit, and so when I click the diver button, it will open the diver window, and here you can see that I have the default monitoring point. My sample method is fixed. The record interval is 5 minutes, and some other useful information is here where you can see the serial number of the diver, the pressure range of the diver, how much memory is left, and how much battery is left. Here you can see the type of diver. So if I want to change the name of the diver, it will automatically select, give you a list of the names that you have already used in your program. So you can select from that, or you can just type your own name in the text box here. Then you can select the sample method for the micro diver. You have several options: fixed, averaging, event-based, or pumping test A, B, or C. I'll leave it to fixed now. I set the record interval to once every hour. So if you paid close attention, you've seen that as soon as I changed something on the settings here, the start button became unavailable. So first you have to program the diver before you can start it. If you made any mistake on this, you can just hit settings and it will reload the current settings of the diver. So when I hit program, it will program the diver, and it will then read the settings again. So now I'm sure that this is what I programmed. And it still stopped, so now I can start my diver. And I can give a future start. And by default, so this is today, and you will see that it will start at 1 o'clock, and you see it's almost 2, but I selected my project time as standard time and not as daylight savings time. So if I sync the diver time with the project time, then the project time is 12:38, and that will be synchronized with, or will be set into the diver, and then it will start at the next available hour. So when I hit start, it will start the diver. You will see that the memory will be set, or the number of samples taken will be set to 0. And you will also notice that the status of the diver will be shown on top here, which is now future start. So now I'm ready to deploy the diver in a well, and it will start logging automatically. So, almost coming to the end of the presentation. Where's my data? Most of the data that you collect will be in the project folder that you set in the project settings. And some people like to back up the database, which is not a bad plan. And depending on the version of Windows that you're using, the data is in C Program Data Diver Office, and for Windows XP it's a slightly longer name. I have that folder open somewhere on my computer. Oh no, not. So if I go to the folder where the data is, you will see here is the demo project folder with the data. So if I go in here, you will see that there's a mon file folder with all the different mon files that I exported. And the database file is called whi.sdf. And if you want to back up your data, it's sufficient to make a copy of this file here. Or if you want to put it on a different computer, just make a copy of this file and put it on the other computer. So some useful links are the Diver Office website. There's some materials on there that will help you. I also entered the download link here, and there's a document on barometric compensation that guides you through the steps that I went through before. And that brings me to almost the end of the webinar. And I'd like to open it up for some questions and hopefully some answers. There's a question. Okay, can you read the question?
Could you demo use of depth to water field measurement to calculate cable length when conducting barometric compensation?
Okay, so let's get my program here. So first, I need to enter a manual measurement, and I need to make sure that it falls within my diver and barometric data. So for this time series, I know that it's the barometric data and the diver series overlap, so I just need to make sure it's overlapping here. So if I go to my manual measurements here, I can enter a new manual measurement. So I just need to make sure it's somewhere in this time frame. So just for convenience, I'll just put it, let's put it 5 minutes after the hour. And if I enter a manual measurement, so if I enter 23 meters, then I'll save this. Then I'll go back here and then compensate, select the center option and select get the cable length, the diver position from the manual measurement, and then if everything went well, I should be able to compensate. So now it asks, because the data was already compensated, if I want to compensate the data again. Okay, so I made a little mistake on entering my barometric or on my manual measurement time interval, so I have to correct that. Okay, I have to put it at the 15th, not at the 5th, so here we go again. So now you see that it's compensated. And so now what you can see from your data is that my manual measurement is at the beginning of the data here. I'll just zoom in here, but it means that my diver or my water level data should be equal to my manual measurement data at the beginning, or at least to be more specific, at the time when I did my manual measurement. So I entered 23 meters, or 2300 centimeters. So the water level at the beginning is 2300 centimeters. So my diver pressure was 1700. My barometric pressure was about 1000. So my water column is about 700 centimeters. So 700 plus 2300, so that means that my cable length will be around 3000 centimeters. So if I now go here, you will see that the calculated cable length is 3000 centimeters and a little bit. So if I select now the calculated cable length, then for any subsequent barometric compensation, I can use the calculated cable length to compensate my data. Is that answering the question?
Yes. Eric has a question. For compensating one point only, is there an easier way than going through the barocomp link?
For compensating?
Just 1 point only.
I'm not sure what he means by 1 point only, but if you can only compensate a time series, there's no way you can compensate only 1 point of a time series. But to compensate only one time series, the right-click method is the fastest way to do the compensation. I think that's what
Can you show the compensation process steps necessary to compensate to known reference datum?
Okay, so if you want to compensate with respect to a vertical reference datum, the only other thing that you have to do is fill out a top of casing value. So that's usually a surveyed value, and let's pick something that I can easily calculate. I just do 100 meters above sea level, and then I right-click on my time series and compensate again. And now I pick the most right option, and I use now the cable length, which is the calculated cable length for this point. And when I compensate, I'll ask if I want to do it again. Yes. And so it has compensated the data. And now you will see the water level above sea level. So in this case, the water level is not mirrored to the diver pressure because the reference sign of the compensated data is the same. So it means that if your pressure goes up, then your water level will rise, and it will rise with respect to sea level. So for the values that we see here now, so the diver pressure is still 1700 minus 1000 for the barometric data is 700. So the top of casing value was 100 meters above sea level. Then the cable length was 30 meters. So the diver position is about 70 meters above sea level. And then the water column was about 7 meters above the diver, so the 7,700 is about the correct value for the water level above sea level.
Okay, the question here, is there a way to have the compensation status be written into the CSV or MON files that you export, as well as cable length used in casing elevation?
Yes and no. So if you export the data, so actually there's two ways. So one is I change this to compensation status, and I'll check this. So now if I want to export my data, I select the compensated data first. I hit View Files. And then here, so this is my data that I just compensated. This is just a flat text file, so I can open it with any text editor. If you don't have Notepad++, you can use Notepad. And in the header of the file, you will notice there is a line, excuse me, compensation status, and it says done here. So if I go back to the other ones, oh, this one is also done. I export again, and now I do the uncompensated data. So this is now, it's the uncompensated data. If I open it with the text editor again, it says compensation status is due. So here you can see whether the water, if the data is compensated or not. And also in the series settings, here, identification, here it says water head, and here it says pressure. So that's also giving you an indication whether the data was compensated or not.
Next question. If I don't have Baro data to compensate my diver data, is there a way to import data from another source?
Yes, there is. It's a little bit complicated. At this moment, Diver Office only allows import of DAT files or MON files. So you need to convert your data into a MON file to import different barometric data. If you have the problem right now, send us an email and we will get you some documentation on how to move forward on that. It's not a very difficult process. You have to enter your data into an Excel file, and then the Excel file formats the data into a MON file format, and you have to save that data as a MON file, and then you can import the data into LibreOffice. So there seems to be no more questions. So I hope it was useful for everybody, and I would like to thank you for participating and for your questions. And if that's it, this is then the conclusion of the LibreOffice introduction. Thank you.